So I'm Darrell. It's my pleasure to have been involved in the project on sewer assessment methodologies. It was about trying to find new technologies for assessing the quality and the reliability and the sustainability of our sewer systems. And really it was all about accessing low-hanging fruit solutions is one way of thinking about it. We're very fortunate to get to work with a whole bunch of different industries, and one of the things we do when we are working with those industries is look at what we call the pulse rate of the industry. So how often do step changes happen? And traditionally the water industry has been very conservative. If you're in the 200 days, pulse rate is about 1.7 pulses per year these days. The water industry is about 0.1. So it's considerably slower. So the good news that comes from that is that lots of faster industries have developed things that can very easily transfer into the water industry. A big part of our methodology is the ability to predict and see what's going to happen in the future. So the reason that's possible is because you can look at some industries that move faster than other ones, look at what's happened in those industries, and then anticipate that the same things are going to happen in your industry. I think fast follower really changed its context a little bit. Someone somewhere has done some hard work for you, but it might be in another industry. So taking solutions from other industries and transferring them into the water industry is a way of getting low risk but much faster innovation. We found some of the biggest insights and solution clues from, for example, the military sector. So people designing security systems where you've got, for example, a picture of people at the railway station and you'd like to be able to recognise a face. So you need very accurate algorithms to be able to pick out certain faces and track those faces. So a lot of their stuff on the software side is something we think can transfer across. On the hardware side, we found a couple of places where there are some very, very good solutions for their own sector. So oil and gas, for example, and getting cameras down into drill heads and boreholes. For them, lost production is a massive cost, so they're looking for very robust systems that allow you to get down into the borehole and to the drill head and see what's going on out there. What they haven't had to worry about too much is cost, and so we can use some of their stuff as a start point, but what we ultimately then need to do is to take what they've done and find ways of making it cheaper and more affordable. The other one, a little bit surprisingly maybe, is the aerospace industry. Their challenges are very different. So difficult to access places, if you imagine fuel tanks and wings, for example, and hydraulic pipes through the aircraft. I need to be able to know what's happening in all those parts of the aircraft, because I need to be sure that everything's operating the way it should be operating. Well, some of the things that we start to see are CCTV is obviously a predominant way of doing things at the moment. So is that going to be there in the future? Answer, it probably is. But are we going to have a person sitting watching a screen to interpret the pictures? Probably not. Because if you look at what happens in other industries, it's a very good idea very often to get the human out of the loop and automate the things that can be done very often more effectively by computers. So there's definitely a future for CCTV, but probably not having somebody manually interpreting the pictures. It's also very likely that other technologies from outside the domain will allow us to look underground without actually going underground, because as soon as you open a sewer cover and go down, then that's money. So it would be great if you could assess the quality of what's happening underneath the ground from above the ground. And there are various component technologies which are starting to do that job right now, so things like radar, etc., ground penetrating radar. The problem is they're just not accurate enough, and so what we try to do is to extrapolate into the future and say, okay, how can we get the accuracy of these technologies, and end up bolting 2 or 3 technologies together that look like they would give us a very accurate way of being above the ground and assessing the quality of the sewer underneath the ground. That was a bit of a long-term one, so what we also tried to do in the project was identify a range of different solutions. So some things we could do in the next few months, some like the radar maybe a few years away, and one of our favourite ones in the middle is the idea of a pill, so something that's flushable, a very low cost, probably a disposable thing that takes photos while it's tumbling through the sewer system and telemeters those photos back to an operator sitting somewhere, which all sounded a little bit Star Trek at first, but we realised that pretty much all of the technologies you need to apply that solution already exist on somebody's shelf, so it's really just a case of bolting them together, and in the space of a few months we could have a working prototype for that kind of solution. The pill was a bit of an oddball one actually, because it came from the medical sector, because there's another sector where a clinician is trying to diagnose what's happening inside a patient, for example, and so one choice is you cut the patient open and see what's happening, but far less invasively is you get to swallow something. And so the idea of having something that you put into the patient with a camera in it is definitely something that the medical industry's been doing, but they've really got a more difficult version of the problem that the water industry might have, because the size of pill that a patient can swallow is fundamentally limited to what I can get past my throat, and so they've had to do a lot of hard work to make things as small as possible, whereas we can now make something that's much bigger and still have it flushable down, for example, somebody's loo. So it was a great project to be involved in, as I say, and hopefully bringing together these new ways of looking at the world allowed us to generate some solutions which hopefully are practically implementable by the fund and by the water companies.